Good morning, everyone. Today we are going to take a look at another FRQ from the same AP exam that yesterday's FRQ came from. So this problem here says for an upcoming concert, each customer may purchase up to 3 child tickets and 3 adult tickets. Let C be the number of child tickets purchased by a single customer. The probability distribution of the number of child tickets purchased by a single customer is given in the table below. Compute the mean and standard deviation of C. Okay. Well, I know that we're given a probability distribution here where we essentially have these are C values, but these are essentially X values like we are normally seeing, and then this is the probability of each of those events occurring. So the probability that 0 child tickets are purchased is 40%. Probability of 1 child ticket being purchased is 0.3. 2 tickets is 0.2, and 3 tickets is 0.1. So I need to think of, okay, what type of variable am I looking at here? So whenever I'm given a probability distribution, this should make you think of a discrete random variable. So it's the number of something. We know that that is our definition of discrete, or not necessarily definition. Our definition is countable and finite. But if there is number of something, that's a good indication that this is a discrete, as well as the probability distribution. Now they're asking for the mean and the standard deviation. So maybe you don't quite remember the formulas for these, but these are actually on your formula sheet. And specifically the mean, well, we didn't necessarily calculate the mean exactly, we did the expected value. But from what we talked about in Unit 5, the expected value is the mean. So when they say the mean, they're really talking about our expected value here. So if I go to my formula sheet, I need to find the mean and standard deviation, or the expected value and standard deviation formula of a discrete random variable. So I go to my formula sheet. Well, these are the descriptive statistics. So these are like mean, standard deviation, slope, all of those. So we're going to keep going. And I see that this one's for probability. So that's the one that I want to look at. Well, this is the OR formula. This is the conditional probability formula. And then I see expected value and variance. So these are the ones for our discrete. Now, they don't give us the standard deviation formula, they give us the variance. So I need to make sure that I note that the standard deviation is going to be equal to the square roots of my variance. So I'm going to have one extra step when I calculate. So let's go ahead and use these formulas. So this says the sum of x times p. So basically in part A here, what that is indicating is I'm going to take so to find the expected value, now we're using C rather than X in this case, so the expected value of C is going to be equal to our C value, so let's rewrite this, the sum, these summations are so hard with a stylus, please forgive me. So the sum of C, and then the I into C means that this is going to just continue for however many values in the table we have. So this is going to be equal to 0 times 0.4 plus, so the summation just means keep adding, plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1, and if I calculate that all out, we should get 1 as our solution. So the mean here, or the expected value, is 1. So then our standard deviation of C, so I'm going to put a little c subscript to note that this is the standard deviation of C, that's going to be equal to the square roots of the variance of C, which is equal to the square roots of the formula that we had over here. So this is the sum of x minus the mean, quantity squared, times the probability. So here we're, instead of using x, we're going to use c. So c sub I minus mu sub c, quantity squared. And then let me fix this because this is the summation of, so we need our sum in here, and then times our probability. So we keep adding until we've exhausted all the rows in the table. So let's put over here. So our first value, so again, this is the square root of this whole thing. So our first value is 0, minus the mean that we just calculated in part A, in the beginning here. So our c value rather than x starts with 0 minus the mean that we just calculated 1, quantity squared times the probability of x. So we have 0.4 here, and then it's a summation, so we keep adding. So we have 1 as our next c value, minus 1 quantity squared times 0.3, excuse me, plus 2 minus 1 squared times 0.2 plus 3 minus 1 squared times 0.1. And if we calculate that out, we get a standard deviation of 1 again. So our mean and standard deviation here are both 1 for part A. So now part B is saying, suppose the mean and the standard deviation for the number of adult tickets, okay, so we're looking at adults now, not children, purchased by a single customer are 2 and 1.2 respectively. So let me just add some paper here. So part B, they're saying the mean of adult tickets is 2, and the standard deviation of adult tickets is 1.2. Assume that the number of child tickets and adult tickets are purchased independent random variables. Compute the mean and standard deviation of the total number of adult and child tickets purchased by a single customer. Okay, so it's saying that these are independent random variables, so I need to combine these since they are being purchased together. So if a single customer purchases a child ticket and adult ticket, we essentially want to know what is the expected value of purchasing adult and child tickets. So essentially what's the mean, and then what's the standard deviation of those combined variables as well. So we have the mean of the adults and the standard deviation of the adult, and then the mean of the child that we just calculated and the standard deviation of the child that we just calculated. So we want to know if we combine these two together, did they define a variable here? No, they did not. So let's just define this on our own. So let's just put T for tickets. So we want to know what is the mean of T and what is the standard deviation of T. Well, we know when we're combining random variables, for the mean, we just need to add them. Since they were combining the adult and the child tickets, we just need to add the respective means. So we're going to do the mean of adults plus the mean of children. So that's going to give us 3. So the total mean of tickets is 3. So this essentially is saying that we would expect the average number of tickets purchased by a single customer to be 3. And now for the standard deviation, so this is the one that's a little bit more complicated. So again, we are adding these variables, but it's important to note that even if we were subtracting, we would still add in our standard deviation, because standard deviation is a distance, so we always add distance. So looking at this here, I need to find the variance first. So if I have the standard deviation of each variable, I need to square it to get my variance. So I need to do 1.2, well, let's just write this out in variable notation. So we need to find the variance and add them. So again, we always add our variance and our standard deviation. So once we find that sum, we can then take the square root to return back to the standard deviation. So here we're going to get the square root of 1.2 squared, put that in parentheses so that's clear, plus 1 squared. And if I crunch out that number, I should get approximately 1.56. So I've just calculated the mean and the standard deviation of the combined adult and child tickets. So now part C is saying, suppose each child ticket costs $15 and each adult ticket costs $25. Compute the mean and standard deviation of the total amount spent per purchase. Okay, so part C, we would say, okay, so the amount spent, so let's just put that as M for money. So we want to know the total mean of the money. So we want to know mu of M and standard deviation of M. So looking at this here, I need to think, okay, so each child's ticket is going to be $15 and each adult ticket is going to be $25. So I'm essentially going to use these formulas that I've created up here, and I just need to factor in the cost per ticket. So the mean of the money that I'm going to do here is just going to be the $15 times the mean of the children's tickets plus $25 times the mean of the adult tickets. So this is going to be, let me move this. So this is going to be equal to 15. We started with 15 times 1 plus 25 times 2. So that's going to give us an average of $65. So that's saying on average we're going to spend $65 for our 3 tickets here. So now we need to calculate the standard deviation. So we're going to do this in a pretty similar way. We're going to use this formula that we calculated above, but we're just going to multiply each value by 15 and square that quantity. So we need to do the square roots of, so 15 times our standard deviation of the child, and then square that whole quantity, plus 25 times the standard deviation of the adults, and then square that whole quantity. So it's important to note that the constants here are also being squared. So we need to make sure that we include that. And so if we calculate this out, we get 15 times 1 quantity squared plus 25 times 1.2 quantity squared. And if I crunch that out, I should get approximately 33.54 as my standard deviation of the money spent. All right, so let me make sure that I've completed this whole thing. I have. So we are officially done with this problem. So now go ahead and you can start the example or the classwork for today, and then we'll be on the Zoom call starting at 8:20. Please make sure you log on promptly since the call will be locked shortly after 8:20 and you will not be able to join after that time. All right, if you have any other questions, please bring those to our call. You can also email me or message me on Google Classroom. All right, have a wonderful rest of your day, everyone.